This video is going to solely deal with giving you a system of how to name. So the learning target is basically when you have all of these different names and formulas mixed together, knowing which of the naming systems to use to get you the right formula or get you the right name. Okay. So what I'm going to do is I'm going to run through a general guideline of how to do this, and then I'm going to apply it. So to start with, you have to ask yourself, the first thing that's listed, okay, whether it's the name or the formula, is it a metal? Because if it is a metal, you're going to follow all of your rules for ionic compounds. But if it's not a metal, okay, then you have a different naming system. So if it's not a metal, the next question is it a hydrogen? Because it's a hydrogen, then that's an acid, and you'll follow acid naming systems. But if it isn't a hydrogen, then the next thing you ask yourself is, well, okay, so it's not a metal and it's not a hydrogen. Is this chemical formula or compound a hydrocarbon? Meaning, does it consist of carbon and hydrogen? Or is it named with that ane, ene, or ine, or alcohol? If it's that, then you'll go organic. If it's not that, not a metal, not a hydrogen, not a hydrocarbon, then it's just your simple molecular rules where you do like the di, tri, pent, and things like that, where you count. So now if you answered that yes, it is a metal, so we already did all the rules for it's not a metal, so yes, it is a metal, then you're naming things in terms of their ions. So it all comes to your ionic compound rules. Look at your metal. Is it a transition metal? Because if it's transition metal, then it will have a Roman numeral for charge, or you'll need to put a Roman numeral on it for charge. If it's not a transition metal, or if it's zinc or aluminum or silver, then you don't need a Roman numeral, and you should know the charge based on the location on the periodic table. Look at the anion. Is that anion made by more than one element? If it's made by more than one element, then that is a polyatomic. But if it's, and then your endings will end in ate or ite. Or if the second one ends in ide, or if it's just a single element, then that will be a single element from the periodic table. So here are 7 examples. What I'm going to do is on the board, I'm going to run through the naming system that I do for these every time in order to create the name so you can see it. So it's up to you how much of this video you want to watch in terms of practice. You can skip through. Once you get it, you can look at the answers. I don't care how you use this video. It's just there for you in order to show you how I go through simple names and formulas, maybe not simple, and then formulas to names. So the first one on this list is calcium chloride. My first question is that a metal? And it is. It's calcium. Awesome. Second question, is it a transition metal? It is not a transition metal. So then I know I don't need to worry about Roman numerals, and I should know the charge from the periodic table. Anion, I look at that and I see that it's an IDE. IDE tells me it's a single element from the periodic table, not a polyatomic. So chloride is chlorine, which is Cl minus 1. I then crisscross to neutralize the charges and come up with the final formula of CaCl2. Next one, calcium hypochlorite. I look at calcium. Is it a metal? Yes, it is a metal, and it is not a transition metal. So it's just Ca. Then I look at hypochlorite. Ite tells me it's a polyatomic. Ite tells me it is not 8. So chlorate was ClO3 minus 1. Chlorite would be ClO2, but this isn't even those. This is hypochlorite, which is 2 less than the original, which would bring it down to just this. Calcium had a charge of +2, crisscross, bring the 2 as a subscript on the outside, erase my final charges, and that is calcium hypochlorite. Next one, perchloric acid. It tells you it's an acid, so you name it like an acid. Ic came from 8, so this is perchlorate. Okay, well, chlorate was ClO3. Perchlorate is 1 more for 4, has a -1 charge, so I need 1 hydrogen. and that is the acid perchloric acid. Calcium is a metal, not a transition metal, so that's Ca plus 2. Hydrogen carbonate, 8 is a polyatomic. Hydrogen carbonate is just a hydrogen in front of the carbonate ion. That hydrogen pulls the charge of carbonate down by 1. So if you crisscross this to neutralize it, you will need 2 hydrogen carbonates. So you put the entire thing in a parenthesis with a 2 on the outside. Hexene is an organic. Hex is 6, so I have 6 carbons. Ene had the rule 2 times the number of carbons, so that's just hydrogen 12. Hexenol is still 6 carbons, but it's an alcohol. The alcohol has a rule 2 times the number of carbons plus 1 more hydrogen for 13, and it also includes an OH, a hydroxide group. For this next part of the video, what we're going to work on is going from formula to name using these rules. So the first one we're going to look at is H2SO3. First question, is the cation component a metal? No. Is it a hydrogen? Yes. When we see a hydrogen at the start of our formula, that tells us this is acid naming. In order to name an acid, you need to determine what your cation is. So SO3 is something, right? Sulfite, sulfate, hydrosulfite, some kind of sulfite or sulfate. We had to memorize SO4 as sulfate. So SO3 is 1 less than SO4, which would make the 8 into an ite. So this anion right there is sulfite. Well, for acid naming, ite becomes us, and for sulfur and phosphorus, we re-add the full elemental name, so sulfur, and then we add the new ending, sulfurous acid. Next one is this. So you check the first thing. Is it a metal? Yes, cobalt is a metal. So now we are dealing with the ionic naming system. So then you look at this and you say, is it a transition metal? Yes, it's a transition metal. So the name of it is cobalt, but you have to determine something to put in the Roman numeral. Okay? Well, you have to figure out the charge on this thing to figure out the charge for this part. So now we ask the question, what is your anion? Your anion, in this case, is a polyatomic. You can tell because you have multiple elements, not just one. There's a hydrogen here, and remember, when we have a polyatomic with a hydrogen, we literally just name the hydrogen, and then we also name the polyatomic component. So CO2, what you guys memorized was CO3 to be carbonate. So this is carbonate. So it's cobalt hydrogen carbonate. That's the name of this formula. The only thing we need to figure out now is the Roman numeral. Carbonate usually had a charge of -2. With a hydrogen added on it, this thing has a -1 charge. You have 3 -1s right here. You basically have this thing 3 times, right, with 3 -1s for a total of a -3. So your metal component has to have a +3 charge overall. Since you only have one of them, that is your charge. So cobalt 3 hydrogen carbonate. Please note there was a hydrogen here, but it wasn't a hydrogen at the start of the name, so it was not an acid. Next one, we have C4H6. First question, is this a metal? No. Is it a hydrogen? No. Is it a hydrocarbon? Yes. You have carbon, you have hydrogen. So we named the hydrocarbon based on the number first. So 4 was named bute. Now you have to figure out what the ending is going to be, and you figure out what the ending is based on how many hydrogens you had. So our basic rule is carbon times 2 So carbon times 2 would be 8. But I only have 6, so this must be carbon times 2 minus 2. And carbon times 2 minus 2 was ine. So this is butane. Okay, I figured out the ending based on the number of hydrogens, just to the fact that it was less than 2 times carbon. First question, is this a metal? No. Is it a hydrogen? No. Is the formula a hydrocarbon? No. So this is just simple binary molecular naming. You name what's here and you add prefixes. So this is nitrogen, and you don't need a prefix because there's just one, but it's at the start. This is oxygen, but since it's the second name, it's oxide. And how many is 2, so it's dioxide. Nitrogen dioxide. One thing to notice, NO2, some people look at this and they say, oh, polyatomic. I know NO3 is nitrate, so NO2 is nitrite. This is nitrite. No, nitrite is a polyatomic ion, which means this is nitrite. Without the charge, it's just a molecule. With a charge, it's an ion. Simple as that. Do more practice. Have a nice night.